system can be defined as the collection or set of numbers. It helps to represent numbers in a small symbol set. There are various types of set of numbers such as natural number, whole number, integer, rational number, irrational number, prime number, and real number. Each type of the set of number has a relationship to each other. So, the next slide, we will see the relationship of the set. The first circle is represented a set of natural numbers. It is also called as counting numbers. Starts from 1, 2, 3, and onwards. It is a frequently used number and denoted by n. Next, natural numbers together with 0 are called whole numbers. So, we can draw a whole number circle around the natural numbers. Integers include all the whole numbers and negative numbers such as -1, -2, -3, and downwards. One important thing that you need to remember is 0 is considered neither positive nor negative. The set of integers is represented by Z. Now I have a question. Are there any number between two integers? Let's say between 0 and 1. The answer is yes. For example, we have 1/4, 1/3, 0.5, or 0.999. And we use this type of number for all the time. So, between any two integers, we have this non-integers number, which known as fraction and decimal. So now, let's go back to our slide. And these entire sets, integers, fractions, and decimal are called rational numbers. Therefore, a rational number is a number that can be expressed as a ratio of two integers in the form of P/Q, with Q is not equal to 0. For example, the fraction 1/3. It is a rational number since it can be expressed as a ratio of two integers 1 and 3. For decimal number, it can be a rational number if it satisfies either one of the following. First, all decimals with terminating decimals are rational numbers. For example, 0.25. It can be expressed as a ratio that is 1/4. The second decimal is which have a repeating pattern after some point are also a rational number. For example, 0.545454, which the digit 54 is repeating continuously. This repeating decimal also can be written as like this. But the important is this number can be expressed as a ratio. It is 6/11. Then it satisfies as a rational number. So we already know about rational number. Okay, I want to give you two examples. The first one is square root of 4. And this number is equal to plus minus 2. Since this positive or negative 2 is an integer, so it can be written in fractional form or ratio as plus minus 2/1 or vice versa. That means square root of 4 is a rational number. Now, I give you the second example. It is square root of 2. This number is equal to 1.41421, which is not satisfy either terminating or repeating decimal. So, the square root of 2 cannot be written as a simple fraction or as a ratio of two integers. This type of number is called as irrational number. Therefore, an irrational number is a number that cannot be written as a ratio of two integers. It is a non-terminating and non-repeating decimal. In the example, pi, it is a famous irrational number since it is a non-terminating and non-repeating decimal number. And also, square root of 2, as already explained before. In conclusion, all rational numbers and all irrational numbers are real numbers. These are the numbers that we normally use and apply in real-world applications. Lastly, we can conclude that natural numbers are a subset of whole numbers. Whole numbers are a subset of integers. Integers are a subset of rational numbers. Combination of rational number and irrational numbers make up the real numbers. Finish our lesson. You can try example 1 inside your lecture note as exercise. Thank you.